Today we're going to talk about complex numbers. Complex numbers are in the form of a plus bi. So they have a real part and they have an imaginary part. And when you put the two pieces together, you get a complex number. And this is standard form, a plus bi. All right, the first thing we're going to do is add and subtract complex numbers. So what if we add parenthesis 3 minus I plus parenthesis 2 plus 3i? Well, when you add two complex numbers together, you just add the real parts together. And then you add the imaginary parts together. So negative 1i plus 3i is 2i. And we usually try to leave our answers in standard form, which that one is. B part, what if we were subtracting them? 1 plus 2i minus 4 plus 2i. Well, just like when we do long division, I don't like to keep up with subtracting everything I get. I draw the line and I change all the signs. I kind of like to do that with these two. I like to change, and flip both of those. So keep the first the same and change the sign to the second one. And then you just add. So we've got a positive 1 and a negative 4 for our real parts. And then we have 2i and minus 2i, which is 0i. And that really is standard form. But we would probably just say it's negative 3. But it is important that you be able to recognize that as standard form. And that's a pure, I don't know if I remember what that's called. A pure real unit? Can't quite remember what that's called when the imaginary part subtracts out. I should look that up. C part, last one of these. What if we have 3 minus negative 2 plus 3i plus negative 5 plus I? 3 complex numbers. We're going to add and subtract them. I do like to change the subtraction signs just so I don't have to keep up with it, and I'm just combining like terms. So the real parts, there's a 3, a 2, and a negative 5. 0. Imaginary parts, you got a negative 3 and a positive 1. And this is called a pure imaginary because the real part has subtracted off or become 0. I can't remember what the real one is called. I don't think it's a pure real. That sounds wrong for some reason. But that is called a pure imaginary. All right, so adding and subtracting, super nice. Just as with anything, when you subtract, you got to be careful. Multiplying, also super nice. What if we have 5 times negative 2 plus 3i? 5 is called a scalar or a constant. So we're just distributing just like normal, and you get negative 10 plus 15i. B part. What if you have 2 minus I times 4 plus 3i? Well, if you're multiplying something with 2 terms each, we're going to FOIL. So we still FOIL. You get 8 plus 6i minus 4i minus 3i squared. Now, I don't know if you remember what I squared is equal to. But if you remember that I is the square root of a negative 1. So if you square both of these, I squared is negative 1. So you have like terms here to get a 2i. And then that is negative 3 times a negative 1, which is a positive 3. I'm showing all the steps, but feel free to skip some of these. And then 8 plus 3 is 11 plus 2i. And that's us finishing it by writing it in standard form. C part. what if you have 3 plus 2i times 3 minus 2i? We got the name of things that are in this form the other day. It started with the C. I thought I had said it before, but I hadn't actually. These are conjugates. These are actually complex conjugates because it's two complex numbers that end up in that a minus bi and a plus bi form. We still just can multiply the a's together minus the b's together. And remember, I squared is negative 1. So that's negative 4 times a negative 1. So it's 9 plus 4, which is 13. Last one. What if you had 3 plus 2i squared? You can square the binomial just like we practiced squaring binomials earlier. You can just do a squared. You can multiply these together for 6i and double it. And then you can square the b. Remember, I squared is negative 1. So that's 9 plus 12i minus 4. So it's 5 plus 12i. Okay. Then we're going to divide, although we're not really dividing, we're writing the quotient in standard form. All this standard form stuff is just math people got together and decided the form they want to leave things in. The earliest you came across it was probably this. You learned it wasn't standard form to leave it if it would reduce. So we learned we had to reduce stuff. Later on you learned you had stuff like this. And it's not standard form unless it's in descending order. And in Algebra 2, you learned that we're actually not allowed to leave a radical in the denominator. That's not standard form, so we had to rationalize. Well, it's actually not standard form to leave an I in the denominator. So if we end up with the quotient, like 2 plus 3i over 4 minus 2i. So we've done some math and we've ended up getting this answer. We're not allowed to leave an I in the denominator. So to undo that, we're going to multiply the top and the bottom by the conjugate of the denominator. And when you multiply by the same thing in the numerator and the denominator, that's really just a 1. Something over itself is a 1. So we're not changing the value of the problem. So we multiplied by the conjugate of the denominator. We're going to FOIL the top, and we'll get 8 plus 4i plus 12i plus 6i squared. And in the bottom, since they're conjugates, we'll get 16 minus 4i squared. To simplify the numerator, we get 8 plus 16i, because you had like terms. And 6 times the negative 1 is minus 6 over 16. Negative 4 times the negative 1 is plus 4. So 8 and negative 6 gives us 2 plus 16i over 20. I call this I love math. I can take this fraction and separate it out to 2 that have the same denominator. 2 20ths plus 16i over 20. And everybody needs to be reduced by 2. That second one will reduce again. 1/10 plus 4i over 5. And you could have, at this step right here, you could have divided everybody by 2 first, and then separated it to 1/10 plus 8i over 10, and then reduced that to 4i over 5. Okay. So it's just not simplest ones. Leave an I in the denominator. And last, we're going to review how to work with radicals. Example 5. If you have the square root of negative 3 times the square root of negative 12. So if we're not taking square roots of negatives, who are imaginary numbers, we're allowed to put them both under the root together and multiply them. But since these are imaginary numbers, because they're square roots of negatives, we have to simplify them first. So square root of negative 3, I won't usually write this, but it's like negative 1 times 3, which is like square root of negative 1 times the square root of 3. And the square root of negative 1 is I. So it's I square root of 3. And I would do the same thing for this second one. Take the square root of a negative, and it's I square root of 12. Now you multiply the i's, and then you multiply the numbers under the radical, and the square root of 36 is 6. Oh, 6i squared, and I squared is negative 1. So your answer is negative 6. So I showed a lot more steps than I think are necessary. So also, it would have been fine if you had broken the 12 down first. It would have just worked out a little differently, but you still would have gotten the negative 6. All right, B part. What if you have the negative, square root of negative 48 minus square root of negative 27. Well, we can't subtract roots unless the roots match. So we, just like fractions, you can't subtract fractions unless your denominators match. So we have to factor this to try to simplify the radicals. Factor it down to primes. And remember, if you have a friend, you can go out to play. But if you don't have a friend, you have to stay home. So a pair of 2's and another pair of 2's. So a 4 gets to go out to play, but the 3 has to stay home. And that was a negative root, so it's got an I. Minus 27, 3 and 9, and 3 and 3. Pair of 3's gets to come out to play, but the other 3 has to stay home. And it's an I, because it is a negative. Now you have common roots. So you just say 4i minus 3i is I square root of 3. Now the book writes it like this, and technically that's right because it should be like bi and not ib, like I'm writing this. But too often it looks like that I is underneath that root. So I prefer to put the I in the front of the root. All right, last one I think is the negative 1 plus the square root of the negative 3 squared. We can do the trick, or we can write it down twice. I think I'll write it down twice. Now, before I get going with this, I need to simplify that root to I square root of 3 for both of them. So negative 1 times negative 1. My outer gives me negative I square root of 3. My inner also gives me negative I square root of 3. And my last gives me I squared square root of 9, or just 3. These like terms are going to combine. Minus 2i square root of 3. And I squared is negative 1. And square root of 9 is 3. So this is minus 3. And 1 minus 3 is negative 2 minus 2i square root of 3. And if you check yourself at the back of the book, they say like this. But do know that that I is not under the root. Okay, good luck. I believe most of those things were a review. maybe some of it was new. But good luck on your work. And I'll see you all Friday.